Okay, so this is where we left off yesterday. We were in the middle of transforming exponential functions, right? We talked about asymptotes yesterday, correct? So we're going to take a look at what happens when we transform this exponential equation and how it affects the asymptote, okay? So first thing I want you to do is we're going to take this right here, this function, 8 times 1/2 raised to the x, and we're going to graph it on the next page. Yeah. It's a stretch because of that value of 8. Just going to change it. Okay. They come up different colors on different calculators, depending on how many functions you have graphed. Okay, so now we're going to graph the second half, but I don't want to put the whole thing into start. I want to start with just this piece here. Okay, and we'll add in the plus 3 after. Okay, 8 times 1/2 raised to the x plus 2. What do you think is going to happen to my original function? It is going to look different. How do you think it's going to look different? Anybody want to take a guess? Okay, so we said yesterday that in order to get it reflect over the x-axis, we had to make what happen? We had to make a negative, right? So we don't have a negative, so we're not going to get a reflection. We're going to get a translation. Do you think it'll be vertical or horizontal? You think it's going to be vertical? You think it's going to be horizontal? I think it's going to be horizontal too. Let's hit enter. Where'd it go? To the left. How many units? 2. So what happened was when I added to the x, exponent, it went left. What do you think would happen if I subtracted? Yeah, it's going to go right. Okay, so you might want to write that down in your notebooks. Okay, so when you add to the exponent, it's going to translate your function to the left, that many units. When you subtract, it's going to translate it to the right. Now, where do you think the up and down is going to go, though? Yeah, so when I do the plus 3, you think it's going to go where? You think it's going to go down? Anybody else think differently? Let's think about when we were transforming quadratics, right? When I had x plus 2, it went to the left. If I had x squared plus 2 like this, where did it go? This gave me right. What did this do? This went up, and then this went, oops, this went down, right? So when I add 3 to the end of this, what do you think is going to happen to my function? I think it's going to go up. Okay, so I'm going to double click right on there and change it from here. If you want, you can hit Control G and do it, whatever's good for you. And I'm going to say plus 3. So we're thinking that it's going to take my entire function, my black function, we're going to shift it up. Currently, what's my asymptote? Asymptote, magical line that a function can never ever touch. What line is it never touching here? The x-axis, and what's the equation of that x-axis? Y equals 0. So right now my asymptote is y equals 0. Okay? Now, what did it do? Move it up how many units? So now where's my asymptote? Y equals 3. Okay, so with that vertical translation, it moved my asymptote with it. It went from y equals 0 to y equals 3. Okay, so that's how we get changing of the asymptotes when you have vertical translations. When you add to the end of the function, it's going to go up. When you subtract, it's going to go down. Okay, do you need me to write those down? Are you going to write them down? Yes? Okay, let's write it down. All right, so if I add to the whole function, right on the end, see how it's on the end? It goes where? Up. And if I subtract, down. And what does that change with it? The asymptote. Very good. Okay. So let's kind of switch gears here a little bit. Yesterday we talked about exponential equations, and when we talked about increasing and decreasing, or appreciation, depreciation, growth and decay, we had a formula, right? What was that formula? Who remembers? A equals 1 plus or minus R. Good. Okay, so we had that formula yesterday, right? So today we're going to look at another formula that has more to do with when we're dealing with bank accounts and compounding interest, okay? In order to use that formula, you guys have to know about the number E. E is actually a number like pi is. What's pi? 3.14159. It's an irrational number, right? We also have the number E, and E is approximately 2.71828. Okay, so it's just another irrational number. It gets used a lot when we're talking about compounding interest or compounding growth, continuous growth. Okay, so you have a couple keywords. You have compounded continuously, or continuous growth. All right, so when you see those keywords, you're going to write down this new formula that we're going to look at in just a second. Okay? In order to use this formula, you have to know where the E to the X button is, and that's right on your calculator. See it here? Okay. That's this kind of E. That's for scientific notation. That's the times 10. It's different. Okay? Not the same, but it's kind of like a fancy E. Like a swirly fancy E. Like it's a swirly fancy I for imaginary numbers. Okay. Or a swirly fancy F for functions. Do you get my point? Okay. We're ready? Huh? Swirly fancy brackets. We like swirly fancy things in math. Ready? Math is swirly and fancy, isn't it? So judgmental. All right. So, we're not going to do this page. Let's take a time. Let's go to 2.15. 2.15. 2.15. It's probably different for you. Okay. All right. So, E is also used when we talk about compounded interest. And again, we have a new formula. A equals P times E raised to the RT. We call that APERT. APERT. Okay? Now, the variables are the same as they were for the last equation that we used. What is P? Yeah, your initial value. Okay, your principal. What's your A? Yeah, your new number, your new value. Your value at the end, what you're searching for. Okay? R? And T? Time. Okay. So when do we use this equation? Compounded continuously, compounded interest, those kinds of problems. Okay, so you're looking for keywords when you do this. Ready? Okay, I'll wait. Control Shift will take it out of caps. Okay, let's give one a shot. Suppose you invest $1,050 at an annual rate of 5.5% compounded continuously. How much money to the nearest dollar will you have in the account after 5 years? Keywords, which is going to tell us to use what formula? Good. Excellent. APERT. Okay. Do we know A? Nope, that's what we're looking for. Do we know P? What is it? 1050. Great. E stays. We need that. That's our base. Okay. What's the rate? How do we have to write it? Yeah, the rate is 5.5%, but it needs to be written as a decimal. What is the decimal? 0.055. And what's the time? 5. Great. Okay, so was it difficult to put into the formula? Not bad at all, right? How do you think I get the answer? We type it in the calculator. Good, because we know where the E key is, right? Where is it? It's next to the 10x. Good. Okay, so you can insert a calculator page and find the solution, please. We'll wait just a moment. Sandra, give me the answer. All right, let's do it together. 10,000, 1,050. All right. So 1050 times e to the 0.055 times 5. That would be the issue. Enter. $1,382.36 is what you should have gotten. Does it say to the nearest dollar? 1382. Okay. $1,382. The money sign is in the book. That's correct. I also think the money sign is in this little thing. Yep. And your question mark as well. Okay? All right. Let's keep moving forward, guys. Okay, very, 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 very important part of the lesson. Solving exponential equations. Very important. Did I say very important? Okay. Now, are you okay? Do you need to go get a drink? Okay. All right, so this is an exponential equation. How I know it's an exponential equation is because it's got variables as exponents, okay? And I want to solve for them. So we wind up looking for what's called common bases. What's the base of the left-hand side? 4. What's the base of the right-hand side? 8. I want a common base. And the way I get common bases is by using exponents, okay? So what base could I use that I could raise to a power to get 4 and raise to a power to get 8? 2, okay? 2 to the what power is 4? 2 squared. 2 squared is 4, do you agree? Okay, so I'm going to rewrite 4 as 2 squared, and then I'm going to keep my exponent. And how would I rewrite 8? Good, 2 cubed is 8, right? 2 times 2 is 4, times 2 is 8. So 2 cubed, 1 minus b. Okay? Okay. Now what do you think I do? How? No. Well, let's deal with exponents. When I raise a power to a power I raise power to a power I multiply. Good. And when I multiply, I'm going to have to remember to do what? Distribute. Okay, excellent. So this becomes 2 raised to the 4b minus 6. And this becomes 2 to the 3 minus 3b. Got to make sure to distribute, right? Okie dokie. Do I have the same base? Okay, so here's the nice part. When I have the same base, all I have to do is take their exponents and set them equal. Okay, so we drop the base, we deal with the exponents. How do I solve that? I don't want to move it all to one side. We don't have a quadratic here. We just have a linear. Sure, let's move the 3b over. How do we move it over? Good. Okay. Good. Add the 6 over and divide by 7. B equals 9/7. And of course, you're going to do what with that? No. What do we always do with our answers? How do you know you're right? You check it. How do we check it? Where do we plug it in? The very original. So I would store B as 9/7, and then I would type this into my calculator, and it should say true, right? So go ahead. I want you to store and check this, please. Store and check in your calculator. I am hot. All right, so let's try another one. This one looks a little different, right? This looks a little different. How do you think I should start it? How do you think I should start it? I do want a common base. I want to get rid of the 5. Awesome. How am I going to get rid of the 5? Add it over. Good. Add it over to the other side. So now we get 3 to the m plus 1 equals 27. Excellent. We want to get that exponential piece alone. You do have this page. It was the same page we were just on, honey.
Oh, really?
Yes. Okay. What's my base on the left-hand side? What's base on the right-hand side? What do I want it to be? 3. Right? Because you can't change this. Can't change that at all, right? So we want to make this into a base of 3. 3 to the what power is 27? 3 to the third. 3 to the m plus 1 equals 3 to the third. Yes, you should always be pressing Control-M before typing in. It's easier that way. Okay. Good. Set those exponents equal. And there's your answer. And you want to make sure to do what? Check it. How you guys doing? Hanging in there? Chilly. Oh, I'm so hot. I don't know. Next page. Yes, Asthma's hilarious, isn't it? Okay. In your own words, write the steps to solve the exponential equation using common bases. What is step 1, guys? Step 1. Find the common base. Step 2. Nope. Step 2. What do we do with the exponents? What do we do? Multiply the exponents. New York State won't allow it. Because there's special. So I know, but New York State doesn't allow that. I'm sorry. If I could change all the laws, I would. Just for all of you. Yes. Okay, 3. Set exponents equal. Are you focusing? Focus. Four. Solve. And 5. Check. Okay. How do we feel about that? Pretty good? We're going to do quite a few more examples, yes. I know this class is going very, very slow. Are we ready? That's good. It means we get to spend more time together. Open your packets, please. It's going to be pages, I believe, 6 and 7. Nope, 5 and 6. I lied to you. Right. 5 and 6. All right. Okay, yell at me. Okay, so let's start with B. Let's start with B. You're on the wrong page. Start with B. I said 6. 6 and 7. I'm sorry, I lied to you. Page 6. B. Okay, just looking at it, can you tell me the base? 2. We were on B, dear, B. Okay, good. 2 to the what power is 16? Okay, 2 times 2 is? Times 2 is? Times 2 is? That's 4. That's plus, honey. Okay, now what? Set them equal. Good. Excellent. How? Great. Subtract 7. Great. There's no reading your book in math class. Unless it's a math book.
If you go and find a math book, you're gonna.
Do they make math books?
Yes. I like to read math books. Nope. How do you read a regular book? That's how I read a math book. Yes, I just read numbers because, that's what I do. I live in this room. I have a cot that pulls out at night. Are you ready? Oh, okay. Now, what do you notice about this one? Yeah, there's fraction. How do we get fractions? Using exponents? How do we get fractions using exponents? How? Something about the negative. Negative what? Negative exponent. Negative exponents give us fractions, right? What's 2 to the negative first power? 1 over 2. Okay, so that's how we get our negative exponents, or our fractions. Okay, looking at this, what's my base going to be? It's going to be 5. If it ends in a 5, chances are the base is going to be 5. Okay? So 5 to the what power is 125? 3. So if I want it to be 1, guys, if I want it to be 1 over 125, negative 3. Very good. Oops. Okay, so 5 to the 4x minus 5 equals 5 to the negative 3. Okay, so really all I did was look at the denominator, figure out what the base would have been normally, and then make the exponent negative. Good, set those exponents equal. Add 5. Good. How you doing? Okay. All right. Didn't come back up. Okay, number 2. I just want to talk about this. I don't want to do it. If I want to know how to solve this algebraically, it's a system, right? And they're both y equals. What do? Set them equal to each other. So you should probably take that note, because when you do your homework tonight and you're wondering, how do I do this? They're both y equals, and it's a system. So what do? Set them equal to each other. How do I find x-intercepts algebraically? Plug what in for y? 0. Okay, so to find the x-intercepts, you're going to plug 0 in for y, and then solve. So you'd add over the 32, find the common bases. Okay. let's do number 4. You can't do number 5. You cross number 5 off. You can't do it. We haven't talked about sign yet. Okay, so for this one, notice I've got the x squared plus x. So that means we're actually going to have to wind up factoring here. Okay, when we get our common bases and move forward with that. What's my base going to be? No? 3. Okay. 3 squared is 9. And what I did is I just kept putting in 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and figured out what it was, and it's actually 3 to the fifth. That gives us 243. Okay. Multiply the exponents, and I have to make sure I do what? I got to distribute. So 2x squared plus 2x equals 5x plus 5. And notice I skipped that step. I went right to setting my exponents equal. You can do that. Same thing. There are no like terms to combine at the moment because I have to do what? Got to get them all to one side. If it's quadratic, if you have that x squared there, you're going to factor it, which means we want to get everything to one side. Move the 5x and the 5 over. So I subtract 5x. We get 3x from here to here. Subtract 5. And we have to factor. And we know it's going to be 2x and 2x and x, right? And my only factors are 5 and 1. So let's try 5 and 1. How do we see if it's right? We FOIL, yeah. 2x times x is 2x squared. 2x times 1 is 2x. 5 times x is 5x. 2x and 5x. Could it give me 3x? Sure. What's going to have to get my negative? The 5. Always the bigger number. Okay, always bigger number gets the sign. Good. And solve. So we get -1 and 5/2. And of course, you'd want to chuck them back into the original to make sure that they work. Okay, but for the sake of time, since the bell's going to ring in about, 30 seconds. Okay, so you're going to finish these 2 pages for homework. And that's it. Okay.